this using the Fluent validation library. I'm going to install the one with dependency injection extensions so that I can also register my validators from the same assembly. Let's close this down, and inside of this file, let's create an internal and sealed class called createEventCommandValidator. It's going to implement the abstract validator base class, and I can specify the createEventCommand as the generic argument. And this allows me to define a set of rules for my command. For example, the title should not be empty, but I can also apply much more complex rules than this. Let's also apply the same rules for the description and the location. I also don't want to allow the start time of the event to be empty. And for the end time, we can define a more complex rule. So let's say for the ends at UTC, we can define a custom rule using the must method. Now I can provide a delegate that's going to give me access to the command object and the ends at UTC value. And then I can say if the ends at UTC is greater than the command starts at value. So this makes sure that we can specify an end date that is before the start date. However, I only want to apply this when the command ends at UTC has a value. And this is how we can simply add validation for our commands. And how we can register this is by going to the events module, and here I will have access to the add validators from assembly method, and I can again specify my assembly reference. So I will say application assembly reference and then the assembly object. And then another important argument that you need to specify is include internal types to true, because I want my validators to only be visible inside of the application project. And specifying this value when registering the validators will take care of that. Now let's go back to the create event command handler, which is only implementing some CRUD logic. A big red flag when working in a domain-centric architecture and applying any kind of domain-driven design principles is having public setters on your properties. So this is the next refactoring I want to make. I will make all of my setters inside of my event entity private, because I don't want to allow anyone outside of the scope of this entity to modify these values. So then the next question is, how am I going to create an event instance? So we can start by creating a default empty event constructor. This is going to be useful for EF Core when it's materializing this entity from the database. But for our use case, we're going to create a static factory method that's going to return an event object. So let me create a public static method returning an event, and let's call it create. This method is going to need a few arguments, so let's add the respective arguments for the properties that we need to set on the event entity. So the title, the description, the location, and then toDateTime object starts at UTC. And we're also going to need another one for the ends at UTC, which is going to be a nullable datetime object. The implementation here is going to be very straightforward. So we can just create a new event because we have access to the constructor, and I'm going to assign the same values as in our use case. So I'm going to say GUID, new GUID, and then let's assign the title, the description, the location, the starts at UTC time, and the ends at UTC time. And now we can just return our event object. If I go back to my use case, you will see that it's complaining that we can't set these property values. So let's go ahead and remove all of this. And what we're going to have instead is calling the event create method. From the command that we get in, we're going to pass in all of these values. So let's pass in the request title, the request description, request location, request start set, and ends at time. And this is going to give us back the same event object. So I'm slowly starting to push the logic down into my domain layer, which is going to allow me to apply some other technical design patterns from domain-driven design. And the first one that I want to introduce is being able to raise domain events. So let's go ahead and create an abstraction. There's going to be an interface representing my iDomain event. Now on this interface, I'm going to define two properties. One is going to be an identifier for this domain event, and the other one is going to be when the event occurred. Then I will need a way to raise these domain events. So for that, let's create a public abstract class called entity, and I'm not going to concern myself with the identity of an entity. I think most of that is pointless. What I am going to do is to define a collection of domain events, assign it a default value to start out, and I'm going to expose a few methods. First, let's start with a protected constructor, and then let's create a method, for example, to clear the domain events. All we're going to do here is say domain events clear. This will be useful when we are collecting the domain events and doing something with them. We're going to tackle this a bit later. And I'm also going to add one more method that's going to be protected, which means it's only going to be available from any types implementing an entity. And let's call this the raise method, which will accept a domain event. And we are just going to append the domain event that we get to the list of domain events. It might also be useful to expose a way to fetch the current list of domain events. I'm going to expose it as a read-only collection of iDomain event objects, and I'm going to return this by creating a new copy of the domain events collection by calling toList. Now, with our entity class in place, let's go ahead and implement it from our event type, and then I can go ahead and raise a domain event from my create method. And now we are starting to make something interesting. So the next thing we need is a domain event. Let's create a class that's going to represent a domain event when an event was created. And I know this sounds a little bit confusing. So let's call this event created domain event. It's going to accept the event ID as the argument, and it will implement the iDomain event interface. Now, the reason I'm creating a primary constructor is so that I can assign a value to the property and also have a constructor. And now I can go ahead and raise a new event created domain event and pass in the event ID. And now we are slowly starting to implement an event-driven architecture approach, because these domain events are going to allow us to trigger side effects inside of our module when something happens. In this case, we are creating a new event entity. And instead of triggering any side effects from our use case right here, what we are going to do is raise a domain event. Then any interested parties in this domain event can subscribe to it and trigger the side effects that they want. Currently, this is complaining that I'm not implementing the required properties on the domain event interface. So I'm going to solve this with another abstract class called domain event. And this is actually going to implement my interface. Let's give these two values an init setter. And I'm going to define two constructors for my domain event type. The first one is just going to assign some default values to the identifier and the occurred on UTC time. So it's going to set the ID to a new GUID and the occurred on time to the current UTC time. And I'm going to create another constructor that's going to take in some concrete values. So an ID and a datetime object representing occurred on UTC. Of course, it's going to set the respective properties. And I'm doing this just to make it a bit simpler in how I can define my domain events. So if I don't specify a base constructor, the default one will get called. And this is for a new domain event. And I want to generate an ID value and when it occurred. For an existing domain event, we're going to call this constructor, specifying the event ID and when it occurred. Let's go ahead and clean up this file by moving these types into their own files. So let's move the entity, the iDomain event interface. I'm going to leave the event created domain event for just a moment because I want to discuss this a bit further. But inside of my domain project, I'm going to create an abstractions folder, and inside of it, we're going to move the entity, domain event, and iDomain event types. I'm also going to adjust the namespaces for these types. So what did I want to bring up when it comes to domain events? I wanted to discuss the potential confusion between an event entity and a domain event. Now, this is an unfortunate side effect of us working in the event management system domain and having to use the event as a central entity inside of our domain. The point here is that we need to make a distinction between the event as an entity and a domain event as a concept of a fact that has occurred in our domain. In some of the next lessons, we are also going to introduce integration events, which are going to be used to communicate between different modules, while domain events will be used to communicate inside of a single module. So now let's go ahead and move the event created domain event into its own file, and let's go back to our use cases. First, let's examine the create event command handler. we started with a domain model that had public setters, which we encapsulated inside of a factory method. This allowed us to raise domain events that we will use to integrate with some of the other use cases that we want to implement inside of this module. For example, we could handle the domain event and publish our respective integration event that will be consumed by other modules. We also moved away from EF Core in favor of repositories and the unit of work pattern, which is going to make our use cases more testable. And we also started using Mediator to describe our commands and queries. And the main reason I'm doing this is so that we can leverage Mediator's pipeline behavior for solving cross-cutting concerns. A few improvement points here would be adding some validation to the create factory method, which I am going to do behind the scenes, and we're going to review the changes in the next lesson. And this brings us to the end of this lesson, where we refactored the solution to move from vertical slice architecture into a more standardized clean architecture approach. And this is actually my pragmatic clean architecture approach, where we are using CQRS and then the repository and unit of work patterns for the commands, and Dapr and writing raw SQL queries for better performance in the query side. Make sure that you watch the next lesson, because I'm going to finish the events module, add a few more entities, many more use cases, and a few refactorings to the current design that I'm going to discuss as part of that lesson.